We're going to talk about applications of trig functions today. So we're going to look at Ferris wheels. And so the first question says, a Ferris wheel is 20 meters in diameter and is bored at the 6 o'clock position from a platform that is 4 meters above the ground. The wheel completes one full revolution every 4 minutes. At time is 0, you are in the 3 o'clock position and ascending. So I'm going to start by drawing a picture. And so we have that this is going to be 20 meters in diameter, that we are 4 meters above the ground, and that at time is 0, which should be right here, we're at the 3 o'clock position. And so what's important to keep in mind is that in these situations, your x value is your time and your y value is your height. And so we're going to go around and create xy coordinates for each quarter of our Ferris wheel because there's 4 quadrants in a unit circle. So what time is 0 here? We have 0. And we need to figure out how high are we above the ground? Well, we're this 4 meters here plus half of our diameter, which would be 10. So 10 and 4 together make 14. So now if it takes us 4 minutes to go all the way around, that means when we get all the way back to here, we're going to be at 4 minutes and 14 meters in the air. So now if we want to go halfway around, that's going to take us 2 minutes, and we're still at 14 meters in the air. If we go halfway to that, we're at 1 minute, but now we've gone from 14 up an additional 10, so now we're at 24 meters in the air. So as you can see, we're counting from time is 0 to 1, 1 to 2, so then we're going to go 2 to 3. So it's going to be 3 minutes, and we're only going to be the height of the stand, so 4 meters above the ground. Now we want to sketch a graph. And so we want to label our axes as time and height. And so we're going to count 1, 2, 3, 4. And this would be 0 back here. And then I'm just going to make 3 tick marks because we have a height at 4, we have a height at 14, and then we have a height at 24. So my low one here is going to be 4. My high one up here would be 24. And then put one right in the middle, which would be 14. And now we graph. So we're going to do 0, 14 here, and then 1, 24, and then 2, 14, and then 3, 4, and then 4, 14. And then we're going to connect with a curve, and that's our graph. Now we need to write an expression, so that's just writing an equation. So we're going to say, well, we know that this, since it starts at the midline or looks like an S, that's going to be a sine graph. It has a midline at y equals 14. So that midline at y equals 14 here tells us that we have a vertical shift of 14. And we know that our amplitude is going to be 10 because the distance from that midline to the maximum right there is 10. And then we need to find our b value. Well, it takes us one full rotation here, so that takes us 4 minutes. So to find that b value, we need to do 2 pi divided by our period, and so that gives us pi over 2, and now we write our function. So we're going to say y equals, we had a maximum right here first, and so we're going to have a positive a value, so it's going to be positive 10 times sine. There's no phase shift, so we don't have to worry about anything in with the x except for our b value. So it's going to be sine of pi over 2 times x, and then we're moving up 14 because that's where our midline is. Now it says predict your height above the ground when you have been on the Ferris wheel for 6.5 minutes. So this is our x. So we're going to say y equals 10 sine of pi over 2 times 6.5 plus 14, and we'll put that in our calculator. Now, we're using pi over 2 and 2 pi and all that, so this is in radians, so you want to make sure that your calculator's in radian mode. And when you do that, you're going to get approximately 6.9 meters as your final answer. So now we have question number 2. When you ride a Ferris wheel, your distance from the ground varies sinusoidally with time. You find that it takes you 3 seconds to reach the top, which is 43 feet above the ground. That the wheel makes a complete revolution every 8 seconds, and the diameter of the wheel is 40 feet. So if we want to draw ourselves a picture, and so it takes us 3 seconds to reach the top. So up here, our time is 3, and it tells us that we're 43 feet above the ground. And then we know it tells us that our diameter is 40, so that means the distance from the top to the bottom is 40. And the radius of this is going to be half of that, so that's going to be 20. And so if it takes us 8 seconds to go all the way around, we want to figure out how long does it take us to go each quarter of our circle. So we're just going to do 8 divided by 4, which is 2, so it takes us 2 seconds to go each quarter. So if we think about the fact that the top is at 3, I'm actually going to move backwards, because if we subtract 2 seconds from that 3, we're at 1 second, which is not negative, so that works. And so it's going to be 1, but now we're going down 20 feet, so it's going to be 23 feet above the ground. Now from 1, if we were to go back 2 seconds again, we're now negatives, and we can't have negative time, so we can't go back again. So now we're going to work forward. So we're going to work forward from the top at 3 seconds, and so over here, it's going to have taken us 5 seconds to get there, and we'll be 23 feet above the ground. Another 2 seconds, it's going to take us 7 seconds to get here, and now if we go from 23, we're going down another 20, so we're going to be 3 feet above the ground, and then we have to go all the way back because we need to stop where our first point was, so it's going to be at 9:23. And so looking at this picture, actually, it tells us that where our ride is starting somewhere in that area. That's where time 0 would be. Now we want to sketch a graph of the situation. So make sure to label time and height. And so we're going to just count by ones on time, but we have to go all the way up to 9 because of the 9 right here. And then again, make it one low tick mark, one high tick mark, and one in the middle. And then our low height is the 3, so we're going to put a 3 right here. The medium height's the 23, so that's going to go in the middle. And the high height is 43, so that's going to go at the top. And now we graph. So we have 1, 23, 3, 43, 5, 23, 7, 3, and 9, 23. And then we're going to connect with our curve. And now we'll write an equation. So looking at this, our starting point is right here. And so that tells us that this would be a sine graph, because looking at our period, it creates an S-like shape. So it's going to be a sine function. So then we also want to note that our amplitude here is going from this midline up to the maximum, so it's 20. We have a midline at y equals 23, and so that tells us that our vertical shift is 23. We want to find our b value, so b equals 2 pi divided by our period. Well, we started at 1 and ended at 9, so that was 8, and so that gives us pi over 4. And then we actually have a phase shift here as well, because we aren't starting at the y-axis, and so we have a phase shift of 1. So now we need to write this function. I'm going to write it just below under D because I'm running out of room. And so we're going to say, okay, well, y equals, we're hitting a maximum up here first, so it's positive, and then our amplitude, it's sine of, our b value is pi over 4 times x. Our phase shift is 1, but remember it's always opposite, so instead of adding 1, we're going to subtract the 1. And then our vertical shift is 23. So the next question says, what is the lowest you go as the Ferris wheel turns, and why is this number greater than 0? Well, the lowest that we go is 3, and the reason it's greater than 0 is because if it was 0, we would hit the ground, and that wouldn't work. So now predict your height above the ground when t is 6. So this is going to be our x is 6. So y equals 20 sine pi over 4 times 6 minus 1 plus 23, and again, you want to make sure your calculator's in radians mode because we're using radians to find all this information. And when you do all that, you're going to get that it's approximately 8.9 feet.